This is part 2 of the assignment help that I'm giving you online. And there are 2 questions in this batch. The first question is about an object traveling such that it has a momentum of magnitude 29.1 kilogram meter per second and a kinetic energy 229 joules. See, you're given the momentum and you are given the kinetic energy, right? And you're asked to find the speed of the object and the mass of the object. Okay, what is kinetic energy? Kinetic energy is 1/2 times the mass times the square of the velocity. And what is momentum? Momentum is the product of mass and velocity. Now, since you have these 2 equations, divide the first by the second. So you're going to divide equation on top by the equation down. So on the left hand side, you're going to get kinetic energy divided by momentum. So dividing 1 by 2, Ke by P. And on the right hand side, you're going to get mv squared by 2 divided by mv. Okay, the masses get cancelled. Oh, that's a mistake. The masses get cancelled. And when you rearrange, you get velocity is 2 Ke by P. Yeah, I've crossed out the mass now. Remember, the masses were already crossed out here, so that's a mistake. I've crossed out the mass. And when you rearrange, you keep velocity on the right side. Take 2 to the left hand side, it goes all the way here. No other change. So it's 2 times Ke divided by P. And now you can substitute. Kinetic energy is 229, momentum is 29.1, and you get the velocity as 15.7 meter per second. But now you have to find the mass of the object. We do know that kinetic energy is mv squared by 2, and we can actually square this whole term. No, here I'm multiplying by m and dividing by m on both sides. So multiply and divide. And the idea is to get the m here to be squared, as you will see. So you get m squared, v squared, because that's 2 m's here. And in the denominator you get 2m. Now, what's the advantage of that? This can be written as the square of momentum, because remember, momentum is just mass times velocity. Since you have both the terms squared now, we can write it as p squared. Now this is a very important equation that gives the relation. Now let me write that again. On the left hand side you have kinetic energy, on the right side you have this. I'm putting them together. A useful equation. We can rearrange this equation to make mass the subject. Just bring mass there. Kinetic energy goes down. So you have p squared divided by 2 times the kinetic energy. You know the momentum is 29.1, so square root 2 times Ke is 229. And when you calculate, you get 1.85 kilograms. So that's how you find out the velocity and the mass. In this question, the second one, you have 2 objects with masses represented by m1 and m2 moving such that their combined total momentum has a magnitude of 17.2 and points in a direction 71.5 degrees above the positive x-axis. Object m1 is moving in the x direction, so that's object m1, and it's moving at the speed 2.92. m2 is moving in the y direction with a speed of 3.09 meter per second. You got to find the mass of each object. So we have the combined total momentum, which is the resultant of these 2, right? How do you find the resultant of these 2? By joining the tips of the vectors. No, just by joining the tip of the 2 vectors. There you go. and this angle is 71.5 degrees. This is 2.92, this is 3.09. Cool. That is 7. Now the idea here is that if you take the components of 17.2 along the x and the y, which I've tried to do here again, along the x, that's going to be the cos component, this is going to be the sine, because this is the adjacent side, this is the opposite side. Okay, when you take those components, you must get the momentum of each one of the objects. Now, so this is 17.2. When you take the component on this side, you get 17.2 cos 71.5, which should be equal to mass times velocity of the first object. The velocity of the first object is 2.92. Rearrange that, you get the mass. That's 17.2 cos 71.5 degrees divided by 2.92. On calculation, you get it as 1.87 kilograms. Do the same thing with the other component. Now, the y component, this one, is going to be 17.2 sine 71.5, which should be equal to the momentum of the second object, which is mass times its velocity. Once again, rearrange this equation, make mass the subject, and on calculation you get 5.28 kilograms. So this is the second unit, and hopefully you have understood these two questions, and I'll be posting more questions, so share it and convey the message to the others so they find it useful too. Thank you.